So imagine that I'm inside the classroom right now, and that I have to walk around the classroom to talk to a number of a number of students. So I'll be moving from point A to point B. Please have a look at the legend at the bottom here, that triangle. Please have a look at the legend at the very bottom. We have a rectangle around 1 meter wide. So I am moving from A to B. The distance traveled is around 11 meters. So imagine that I traveled that distance in 1 second, pretty quick, eh? Use the formula, speed equals to distance over time. The distance was 11 meters in the time was 1 second, so therefore the speed is 11 meters per second, pretty quick. Now have a look at the top right corner. We have direction there. Let's imagine that I'm moving to the east, trying to assist one of our students. I move to the east. It's the very same distance. Now I use the formula. Delta x is equals to fx minus x0. The changing displacement here, the changing position, is 11 meters minus 0, which is my initial position. It turns out that the displacement is 11 meters east. The displacement and the distance, they look very similar. However, they are two different concepts. Now, another example. Let's imagine that I have to move from point A to point B. So I decide to move and I go east, then I go south. You would imagine, whoa, we can add the 11 meters across here, plus the number of meters that he travels south. But it turns out that the displacement, remember, is the shortest way from point A to point B. So no matter how distant, how many times I could have gone back and forth, and back and forth here, the displacement is still point A to point B. We use the same formula, and the displacement is also 11 meters, but now the direction is southeast. Another example here, imagine that I have to move to point A again, but that's the path I take. I think you know what I'm going to say here right now. The displacement is the same. The path is different, but the displacement remains 11 meters southeast. Now the last example for the video. Let's see where I am going. The displacement from point A to point B and backwards. So remember, I moved from point A to point B using a number of different pathways. It wasn't a straight line, you saw that. And then I came backwards. So it's your turn to tell me what was my displacement. I encourage you to stop the video now and to use the formula to get to the solution. 0, yes, 0. Think about this. Let's use the formula to answer that question. So my final position was back where I started. And my initial position was stopped. I was standing still. So 0 minus 0 is equals to 0. My displacement was 0. I covered ground, I covered some distance, but my displacement was 0. That's the formula there filled up. I hope you understand that. Vectors and scalars, that's a nice image that I found on the NASA website. And that image is showing what are the units, the quantities for scalars and the quantities for vectors. Vectors, we'll talk about displacement, velocity, acceleration, momentum, force. Whilst scalars, they talk about things that have no direction. So the length or area or volume speed, mass, density cannot have a direction. You don't talk about 1 meter in length to the east, 1 liter of water to the south. You don't talk about things like that, but you talk about acceleration to the west, displacement to the north. The most important scalar to us right now, it's the speed. And we know that the speed, it's another way of saying that how far we travel in a certain period of time. That's why we use that formula. Speed is equals to distance over time. Mr. Silva, you are confusing me now. No need to be confused. That triangle there is just showing all the possibilities that that formula can give you. Possibility number 1 is distance is equals to speed times time. If you want to know the distance, that's what you use. If you want to know the speed, is speed equals to distance over time. And if you want to know the time, it's time is equals to distance over speed. So it's time for action now. You can now start working on your speed versus displacement assessment. The due date is the 3rd of June 2016. You can watch this video at any time. You can make your comments. If it's too long, please make a comment. If it's too short, please give me your suggestion. I'm more than welcome to listen to you and to improve, okay? I really hope you enjoyed this video, and I'll see you next time.